Hello everybody, and welcome back to another GIS Mathematics lecture video. And in this lecture video, I want to go through another example of cofactor expansion. And this time I want to go through a row expansion. So I'm going to use the same matrix we used from before. So I'm actually going to take this matrix here, and then we're going to do the cofactor expansion of the second row. So let me just quickly copy this matrix. Let's give ourselves a little bit of space here. So we've got our matrix again. And then I want to quickly remind ourselves of the determinant of a 2 by 2 matrix. Right, so our determinant of a 2 by 2, right, that A, B, C, D, right, that determinant was just the AD minus BC. So we remember how to calculate that. And so what I want to do in this example is I want to do the cofactor expansion of the second row. Okay. So let's go ahead and look at the cofactor expansion of the second row. So our second row, just to remind everyone what we're looking at, is going to be this row right here. And cofactor expansion, again, we're going to write the equation out and then we're going to go through and fill in the pieces. So cofactor expansion of the second row, so that's going to be the value of the second row first column times the cofactor of that second row first column, plus we're going to add the value of the second row second column times the cofactor of the second row second column, plus the value of the second row third column times the cofactor of the second row third column. So again, just to make sure that nobody's lost with where we are here, right, we're looking at the second row. So all of these are going to involve the second row. And we want to make sure that we do each column in the matrix. So that's column 1, column 2, and column 3. And we're just multiplying the value at that location times the cofactor that ignores that row and column. Okay. So hopefully everyone's on board with what we've set up just sort of conceptually here. Let's go ahead and start filling in some of these values. So again, the determinant will be making 2 by 2 matrices. So the determinant is going to be this. So we're just going to apply this to each of the cofactors. So let's see. What value is in 2, 1? Well, row 2, column 1 is 4. So this is going to be 4 times the cofactor of 2, 1 is going to be negative 1 raised to the 2 plus 1. And then we're going to multiply that by the determinant of, we're ignoring the second row and the first column. So this is going to be 2, 3, 8, 9. And then we're going to add to that the value of the second row, second column, second row, second column. That's going to be 5 times negative 1 raised to the 2 plus 2. Right, again, I'm just following that equation for the cofactor value. I'm sticking it into the cofactor expansion equation. So negative 1, 2 plus 2, times, again, the determinant. And this time we're ignoring this row and this column. So we're going to have 1, 3, 7, 9. And then finally, we're adding the second column, third row, or sorry, second row, third column, which is going to be 6 times the cofactor, which is negative 1 raised to the 2 plus 3 times the determinant of ignoring the second row, ignoring the third column, which is 1, 2, 7, 8. So now we can go ahead and we can start evaluating some of these things. So this is going to be 4 times -1 to the third power is going to be -1. If I'm going too fast, I encourage you to pause the video, go back, re-watch the step you're confused about, pause it maybe on that step, and just see what I started with and where I ended up, and listen to it a couple times, and maybe you hopefully you can figure out how I got there. Again, for the determinant, I'm just using this equation here. So the determinant of this 2 by 2 here is going to be -6. So we're going to add to that 5 times -1 to the 4th power is 1. And then the determinant of this matrix here is -12. Again, I'm just applying this equation, AD minus BC, to this 2 by 2 matrix here. Plus, okay, so then we're going to do 6 times -1 to the 5th power is -1 times the determinant of this matrix is -6 as well. Okay, so now let's go ahead and do the multiplication. 4 times -1 is -4 times -6 is +24. Five times 1 is 5 times 12 is -60. And then 6 times -1 is -1 times -6 is +36. So we combine like terms here. So -60 plus 24 plus 36 is also 60. And we get a value of 0. Okay, so what we've done is we've calculated the cofactor expansion of the second row. Again, we applied the same sort of equation where we took all of the values in the second row, so value second row first column, value second row second column, value second row third column, and then we multiplied them by the cofactors, which again ignore that row and column combination. So we ended up with this sort of evaluated equation down here. Do all the arithmetic, we end up with 0. And so what I want to do is I want to sort of hint at something that we're going to talk about in the next video, and that's that if you look at this matrix here, which is the same matrix as our previous example. Let me see if I can slide up just a little bit. Okay. So if you believe me that these matrices are the same, and you should because I copied them, right, you'll notice that the cofactor of the first row gave us 0. Or sorry, cofactor of the first column gave us 0. Let me label that really quick. Right, this is the cofactor of the first column. Cofactor expansion of the first column. Was 0. And then if we look down here at the cofactor expansion of the second row, right, they're the same thing. 0 for the first column, 0 for the second row. And that's not a coincidence. that the cofactor expansions end up the same. And what we're going to do in the next video is we're going to talk about why this is important and actually how this gives us the determinant of larger matrices. So we're going to stop here with this example. Let me scroll back down a little bit. We're going to stop here with this example. Hopefully you're able to follow along. We're going to go through another couple of examples of this cofactor expansion in subsequent videos. But hopefully this made sense, and if you have any questions, please reach out. Thank you.